Assalamualaikum. In this session, we will continue with the methodologies in quantitative and qualitative analysis in HPLC. For qualitative analysis, normally in HPLC, they use the retention time matching, and for quantitative, we normally use standard curve method and internal standard method. What is retention time matching? Let's say we run our standard. What is standard in HPLC? Actually, standard is a known analyte present in our sample. For example, in coffee sample, we know that caffeine is present. So caffeine is our standard. When we run, we got the retention time 10 for the standard, means the caffeine retention time is 10. Then when we run the sample, it come out as two peak. Which one is the caffeine? The one at the retention time 10 is meshed together with the standard. So both we run under the same condition, but two different injection. So that's a disadvantage compared to the TLC, whereas with TLC we can spot the sample with the standards and run simultaneously. Then we just matching. That's the qualitative. Now move to the quantitative analysis. So how we can determine the concentration of our analyte in the sample? So we have to prepare a set of standard solution containing a pure analyte. For example, just now I gave you caffeine. So caffeine will be prepared by a different concentration, 10 ppm, 20, 30, 40, 50, and different concentration have different peak area, and then we have to plot a calibration curve graph, which is the x-axis will be the concentration and y-axis will be the peak area, and the straight line of the calibration curve. After we run our sample, we got the peak area, and then we just put the peak area and then directly determine the concentration based on the standard calibration curve. Next, we can also use the internal standard methods. Internal standard methods, we use the standard solution together with the sample. So inside the sample, we put the standard inside the sample. So we plot as usual and determine as usual, and the calibration curve will be plot, which is the x will be the concentration, y will be the peak area, and concentration of our sample will be determined by the calibration curve. That's two way of quantitative analysis can be used in HPLC. Now move to the next part of HPLC, which is instrumentation part. The main component of the HPLC is listed here, which is the first one is mobile phase system, and the second part is pump, the third one is sample injection system, the fourth is column, fifth is detector, and the last one will be workstation. We go one by one. Before we go, we understand the schematic diagram of the HPLC system, and this is the mobile phase reservoir where we put the solvent here, and the solvent will pass through the pump, and the pump before going to the column, the sample also will be injected through the column. Both will pass through the column, mobile phase and the sample, and based on different interaction with the silica gel inside the column, they have a different peak and will be detected by the detector, and they have a different chromatogram, and peak will come up in the chromatogram. So the waste will be the mobile phase that will go to the waste reservoir. This is the schematic diagram for HPLC. Next, we go one by one. What is the function of mobile phase system, also known as reservoir? Here, the Scott bottle. It can be filled. All the solvent can be single solvent or can be mixture of the solvent by different polarities. Let's say you want to put different methanol here, water here, acetonitrate, buffer solution here. Also can, or you can mix all methanol, water, buffer inside one bottle. It also can be do like that. In the mobile phase, the precaution that we need to take care, you have to make sure that the solvent is high pure and will be filtrate and must be degases. And for the buffer solution, we need to control the pH value. This is the membrane filter with the 0.45 micrometer. This membrane filter will be used for the filtration part. And all this filtration, why it is important to remove small particulate matter such as dust and insoluble salt. Why we need to remove? It can damage the pump and collect on the top of the column, means it clog our column. So that's why we use membrane filter with the size 0.5 micron and 0.2 micron for buffer salt solution. That's the next is the degasser. Why we need to degas? To remove dissolved gas in mobile phase such as nitrogen and oxygen. Why we need to remove the dissolved gas? Because it will result in distortion of the signals, and also it can cause the high pressure and unstable pressure through the HPLC system. And after all precaution have been taken, and now it's ready to go to the HPLC system, and the mixing chamber will function to mix all the solvents with the correct composition setup in our software. And the heart of the HPLC, the second compartment, is the pump. Why the pump is function to provide the high pressure or driving force for the run, which is the core component of HPLC. This pump will pump all the solvent and pass through the solvent through the column. And next is the important part is the sample injection system. Sample will be injected through this valve, and this is how this valve is function, because in the loop condition the sample is not injected. Only when go pass through the string or go through the waste, and if we click inject in our HPLC system, it will pass through the column, our sample. This is how the needle looks like. It have a different types. And next is compartment is untitled column. The untitled, what is the function? To separate the annulate in the run. External packing is usually construct from stainless steel tubing. This is a stainless steel. Why you want to avoid of the damage of the silica coating inside the column. So, and this is the brand, and here is the silica coated around the functional group coated around the silica is C18, and this is the size of the column. The length is 150 and the diameter is 4.5 the diameter. And the dimension of the particle size is normally is 1.8 to in the range of 1.8 to 10 micron meter. And why the untitled column? Mostly internal diameter of around 5 mm packed with the 5 micron meter particles, because they offer a good compromise between sample capacity, column efficiency, applied pressure, and volume of mobile phase use. That's why normally untitled column in this type of range of size. Next, the next compartment is column, is guard column. The guard column is the same properties like untitled column. Why sometimes we use guard column? To avoid the formation of clogged column induced by small insoluble particle from sample or mobile phase. Properties is same as a untitled column. They are small column only. The last part is the detector. The detector is normally in HPLC we use the UVVs, or we can call as a DAD or PDA. All this one is used UVVs range of light. And if the compounds is not absorb the UV light, it can be used refractive index detector RI or mass spectrometer detector. That's all for the compartment of HPLC. Thank you.